All right. Good day, everyone. So, in this class, I will be explaining the concept of an Atwood machine. So, an Atwood machine works on the principle of Newton's law of motion. And in this machine, we have a circular part. We have a circular part where a rope is wheeled in the two direction of the circular part, and the rope is connected to two masses. We take the first mass to be M1 and we take the second mass to be M2. These two masses are connected with the same rope wheeled along this circular part. And because they are connected with the same rope, they possess the same tension. And because they have the same tension and connected with the same rope, they possess the same acceleration. The acceleration of the rope or of the bodies depend on the magnitude of the masses connected in the Atwood machine. So we assume that mass 1 is greater than mass 2. If mass 1 is greater than mass 2, it shows that the body is going to accelerate in the direction of M1. And that is why we are going to have the acceleration of the body to be in this direction. So if mass 1 is accelerating downward, it means mass 2 is going to accelerate upward. Common questions that we can have under the concept of Atwood machine. They can ask us to calculate the common tension, and they can ask us to calculate the common acceleration. How do we go about this? How do we achieve this acceleration and the common tension in an Atwood machine? The first thing we have to do is we have to draw the free body diagrams of the two masses. Now, taking mass 1 as an example, this is the free body diagram of mass 1. The weight of mass 1 is acting downward, which is weight 1. Now, because the body is accelerating downward, it means the downward forces is greater than the upward forces. And for the body to accelerate downward, it means the weight that is acting downward minus the tension is equal to the accelerating force of the body. Take for example, I have an object which is 20 Newton in weight, and I want the body or the object to start moving. All I have to do is I have to apply a force that is greater than the weight of the body. So if I apply a force of 30 Newton, it means the body is going to move with 10 Newton of force. That 10 Newton is called an accelerating force. And that is the concept that we are trying to apply in this free body diagram. So the weight minus the tension must be equals to FA. Basically, what we are saying is the summation of all the forces on this body must be equals to the accelerating force. And because the downward force is taken as positive, the upward force is taken as negative. And that is why W1 minus T is equal to F1, which is the accelerating force. So I can say M1 G minus T equals M1A. And I can say minus T equals M1A minus M1G. If I multiply both sides by minus 1, I'm going to have T equals M1 minus M1A. And this is the first equation for the free body diagram of M1. I'll draw the free body diagram of M2. M2. Remember that the body accelerates upward because M1 is greater than M2. The weight of the body is acting downward. Now, for the body to accelerate upward, it simply means the total forces acting in upward direction is greater than the total forces acting in downward direction. So to get the accelerating force here, I have to say T minus W2 equals F2. And T minus M2G is equal to M2A. T equals M2A plus M2G. And this is the second equation. Now, because they have common tension, I can easily equate the two tension and say T equals T. The first T is M1G minus M1A equals M2A plus M2G. And the next thing I do is I collect the like terms. So I have M1G minus M2G equals M2A plus M1A. Then I factorize. So if I factorize G, I will have G into bracket M1 minus M2 equals A into bracket M2 plus M1. And if I make the A the subject of formula, I'm going to have A equals G into bracket M1 minus M2 divided by M2 plus M1. Now, to generalize it, I can say A is equal to G. This is saying the difference between the masses. That is, subtract the lower mass from the higher mass. So I can easily say this is change in mass of the bodies divided by, and I can say this is summation of the mass. That is sum the mass, summation of the mass, where I start from 1 and end in 2 because we have two masses. And this is the formula that we use in calculating acceleration of a body under an Atwood machine. And when you get the acceleration and you are looking for the common tension, all you have to do is substitute the value of the acceleration into one of these equations and we get the common tension. I'll see you guys in the next class where I'll be solving some questions under the concept of Atwood machine. Thank you very much. I remain Ajadio.